Hi, everybody, and welcome to the John Myer podcast. Today's topic is scaling AI ML on AMD in AWS. And before we get to that topic, how about we give our guests a chance to introduce themselves?
Thanks so much, John. And it is such a pleasure to be here with you. So excited to talk about AI on AWS. And hey, guys, my name's Nathan Chang. I've been with AMD for about 2.5 years, and I currently lead a small solution architecture team focused on helping customers deploy AI on AMD in the cloud.
Let's talk about AI real quick. A lot of people are hearing that. They're hearing generative AI. They're hearing AI ML. AI ML has been around for a while. People have been using it. Help the audience understand AI ML and how it relates to AMD.
Sure. So, for the most part, AI, ML, it's just vector matrix multiply. It's just math, right? Multiplying matrices together. What's really awesome about it is able to statistically represent how you can predict certain phenomena, right? And that phenomena could be, like, as everybody's seen, is there a cat in this picture? But it can go all the way out to, hey, let me give you a synopsis of Romeo and Juliet, or let me write you a novel, right? It's actually getting that predictive and that creative. But really what it represents for AMD, it really represents a way for us to make a bigger impact on the world, right? AI is going to be in everything. It's in your phones, right? It's in your TV. It's in your car. It's literally in every aspect of our lives now. And more of that, AI requires more and more compute, right? There's computer chips in everything. And so AMD is a computer chip manufacturer and designer. And we are really we're just excited to help the world deploy AI everywhere that it's needed and everywhere it can make an impact.
Nathan, AI has been around forever. Why is the buzz grown so recently with regards to it?
Because it's never really represented general intelligence, right? When we go and deploy AI, it's very specific. Like, hey, I'm going to deploy a model that's able to make sure that it can recognize that there is a lane marker when I'm driving and tell me when I touch it, right? Very specific. That same model's not going to be able to tell you, whether or not your wife is mad at you while listening to your phone, right? It's not going to be able to recommend to you, what's the next best thing you should be buying on Amazon, right? And again, those all represent separate models. Models now, especially with the advent of self-attentive transformers, which is really the main type of model that's happening in the large language model, or what most people would call ChatGPT. It's generalized, or at least it represents generalized intelligence, right? I can actually have a real conversation with this thing. It will give me very real, coherent, and very specific and relevant answers. And that's why everybody's excited.
Help me understand the difference, and if there is a difference, right? So we've been talking AI, ML. You mentioned generative AI. Is there a difference between generative AI, AI, ML? Because I'm hearing all kinds of buzzwords, and I'm not sure which one's which.
So if we're talking about, say, traditional AI ML, it's a model that's able to give you a very specific prediction, right? I think I gave the example of a model telling you where the lane marker is while you're driving. It's very different when something can really generalize, right? Something that can actually mimic comprehension, and that's why I think that's where generative AI is going, right? It's called generative because it can generate content, right? Whether it can paint you a picture, whether it can, paint the Mona Lisa, or whether it can actually, write a novel, or it could write a blog for you. You give it 2-sentence prompt and it builds you a PowerPoint slide. It's generating content. And I think that's really what people can do. And so there's the buzz.
All right, now I actually understand the whole terminology, Gen AI, AI, ML. companies now are trying to implement their whole AI ML, kind of actually utilize it. What are some of the challenges when they're not only trying to implement it, but scaling it within their company?
So I think that the really big challenge was, at least the big challenge as the public would have seen it, is building an actual model that could do that. And if you take a look at how things have iterated, a lot of it was like closed source, where it was something like OpenAI's ChatGPT model. But what came quickly after it was the open source community. And so I'd say one of the most popular models for companies to actually fine tune and train for themselves and not have to go and build this big foundational model all from scratch would be something like Llama 2. But Llama 2, didn't really have a great start. Its first version was something like OPT. Then there was Llama 1, then there was Llama 2. And truthfully, outside of some minor architectural tweaks, the big change was how much data they used to train these things. That was a big problem. And it's, for the most part, according to, I'd say, the majority of the people in the industry, it's been solved. Those models are very capable and can be trained to do a slew of different things and generalize across a bunch of different tasks, right? Now comes the problem of, okay, these models exist. Now how do I deploy these models where people are able to ask them tens of thousands of questions per second, right?
I'm seeing the correlation now, why AMD, AWS, and the scaling. I know you're getting there, and I'm actually like seeing all the pieces come together.
Yeah, and so remember that these models are big. They're bigger than the models that we deployed just to be able to tell you if there's a cat in the picture, right? That was like maybe 1,000 parameters and maybe on disk just a few kilobytes. Now you're talking about gigabytes and terabytes of model sizes, right? And the memory that is in a single GPU or a server filled with a bunch of GPUs, it's barely getting up there, right? So it's expensive. These devices cost tens of thousands of dollars, and deploying a set or a cluster to serve all these models will cost you hundreds of millions, right? And then to run them at 700 watts a socket, up to 700 watts a socket, it's going to take a couple of power generators.
Nathan, how is AMD helping tackle this problem? And where does AWS come in this picture?
So I think when we work with customers, a lot of the architectures are helping them scale these, a lot of the architectures are moving towards multiple models in a pipeline. And then also you're able to do a lot of data management and a lot of data summarization. A lot of people would use the term RAG in the background so that you can make the model that needs to actually run in the foreground, which would be as in a quick response, low latency model. It doesn't have to go sifting through mounds and mounds of data. You're able to serve up to that model results from a previous model that helps summarize and shrink down the data sets that it needs to draw upon.
Is that like a dual pipeline, like pulling a subset of the data so you can analyze that while it's still analyzing another one or utilizing it?
Similar, right? It's actually creating indices of structured data instead of completely unstructured data, right? So we're helping not just deploy these architectures, but we're helping customers optimize these architectures on our platforms and with our libraries across a slew of different types of models. And so you're going to see customers not have to use GPUs all the time, which are not only scarce. Everybody gets that, right? Like, NVIDIA can't make enough at the moment. God love them.
The faster, let's go.
It's okay. I'm Taiwanese, by the way, so I am a fan, Jensen. Lisa Sue's Taiwanese as well. They're cousins. So, yes, We make GPUs, they make GPUs, they're big and expensive, but that's not always the landing spot for all of these models.
Okay, we're talking about AMD AI and ML on AWS. Are you helping customers decide their architecture on AWS and if it's right for them in order to run and deploy their models and analyze them? And like, what does that look like from an overall customer standpoint?
So yes, we work with a lot of different customers that are deploying these models now, right? I think that when you talk to the majority of the world, they all have this aspiration to deploy this stuff because they can see the value, and they can see the dollar signs on the other side of actually building services with these models, right? Much smarter, much capable services to drive more revenue. But really, it's a pretty small set of customers that are at the point where it's like, okay, I'm ready to deploy this. I know exactly how to do this. I know exactly where my data is and how to engineer it. And so it is quite intimate. You're talking about working with customers that have models, that have data pipelines, and helping them to understand on the software side where they can implement our our libraries to accelerate a lot of these tasks that are starting to look like they will be cheaper to serve in batch, as in high throughput, not about latency, on CPUs.
Nathan, why can't customers do this themselves? Why do they come to you? Why do they come to AMD to do AIML on their environment and to get this done?
Well, there's a lot to choose from out there, right? There are multiple types of CPUs. There are multiple sizes, multiple classes. Obviously, the big ones are us and Intel. But then there's also ARM cores mixed in there. Then on the GPU side, you have our GPUs, you have NVIDIA's GPUs, you have the many different T-shirt sizes. Can't even call it T-shirts.
It's more than T-shirt sizes now.
Yeah.
Oh my God, it's a full clothing store.
Yeah, we'll go with suit jacket sizes, right?
Yeah, actually, that is a very good definition of it and the variation of sizes for it because there's no one size that fits all.
Yes, and helping them understand, because here's the funny thing. There isn't a lot of comparative data out there that compares across platforms. Like, you can definitely compare GPUs to GPUs, and you can definitely compare CPUs to CPUs, but not a lot of that is going across. And there's not a lot of places where people can understand and work with someone to do that. And so we provide that sort of consultative capability to our largest customers, helping them understand how these models are going to run on different platforms, how these models are going to run with different data types, right? And helping them, therefore, make the right decisions around how to architect these environments in a sustainable and a longer-term investment way to save money in the end.
So you're not only helping with the skills gap, right? So a lot of customers that want to do AI ML, you mentioned it earlier, there's only a small set that actually understand that they want to do it. They know what they want to do. They know where their data is, the data sets to use. Outside of those customers, and probably even some of those, you're kind of helping with the skills gap and understanding it, not only the architecture, the design, utilizing the libraries, what is the best method for them, whether it's AMD going with it, the instant types because AWS has variations. Are you helping on the implementation on the AWS side to help implement these, AI ML within their environments?
Oh, absolutely. I'm sure you guys know that we recently deployed Genoa into AWS, and it actually, I think, in a way, actually received a crown, like not a physical crown, but it was actually dubbed, the highest performing cloud compute x86 compute instance. That has definitely given rise to more capability, more throughput on a lot of these larger models, and so customers are. Well, they're really working with us to help them profile these workloads and to sort of fill in a lot of the data gaps. It really just is about data. There's just not enough of it out there about these models and how they run on all of these different hardware architectures. It probably doesn't help that the models change once a week. Yeah.
That definitely makes it challenging. And when you say there's not enough data, I swear there's so much data out there, but there's not enough data underneath the data that we're trying to train and utilize.
Yeah, yeah. And so I think a lot of these infrastructure teams, not the data scientists, but the actual infrastructure teams that need to build standards, right? That need to be able to support, these production models and operations. They've done this for a lot of traditional workloads, database, web serving, Java, right? This is so much bigger from an investment perspective comparatively to any AI ML that people have deployed previously. Easily between, 4 and 10 times more, because it's becoming that much bigger, but that much more of the value generation of a lot of these companies. It's happening faster than they're able to evolve. So we are just doing our best, honestly, to support these customers with just the data that they need to understand how this stuff performs so that they can make the right investment.
Nathan, what does the future look like for AI ML, but also AI ML with AMD?
Oh man, yeah, I think there is definitely there's definitely going to be a curve, right? To really ramp the deployment of all these transformers, all of these Gen AI models. And I think obviously there are going to be a lot of winners and losers, but the majority of the world, I think, is really going to deploy a lot of open source, right? Because a lot of the data that people are using to train, to fine tune, to even serve these models is pretty proprietary and things that they want to protect. I think that you're going to see these models become more capable. You'll see them shrink in size and be deployable on smaller architectures over time, like your phone, like our laptops, maybe even into smaller chip architectures, like into small devices. And I think for AMD, you're going to see a lot. You've already seen what we can do in the data center with AMD EPYC, with AMD Instinct GPUs, but recently we finally deployed new versions of ROCm that allow you to run AI and ML workloads on our gaming cards and our workstation video cards, right? I think you're also going to see us continue to grow the heterogeneity of our chiplet architectures. I think the first iteration of that was in Ryzen AI, where we actually deployed AI engines into Ryzen laptop CPUs so that you could accelerate a lot of the AI ML that's running in the background for things on Windows and Office 365 and even like Zoom calls. But I think what you're going to see is us continue to grow that heterogeneity and really grow the capability of compute engines from AMD to do more with AI.
Well, we know that running high-intense workloads, not only within a data center, within AWS, all these data sets are utilizing so much CPU and so much consumption. How is AMD helping address that issue?
You mean all of the, like how data intensive it is?
Yes.
So I think that it's going to be not just us, right? We have to work with our partners. We have to work with companies like AWS, like the database vendors. What you're going to see is more training and inference happening within those kinds of structured data services, right? Because one of the biggest problems with the architecture landscape and how infrastructure is deployed right now is that you constantly have to move data too much, right? Once I move it into a server, I should be able to do everything that I need to do with it and not have to send it to a separate set of accelerators. And so I think what you're going to see is that a lot of these software companies that provide, infrastructure level like a database server, They're going to do more in situ AI inference and training because we're going to provide them with the compute capabilities so that it doesn't have to move.
I think that's actually huge. Just moving your data around takes so much time, so much energy, so much consumption. It's a delay in the processing, a delay of analyzing it. I mean, 1 gig isn't bad, but when you're moving petabytes of data, it takes a while. And then by the time you get it there, you could analyze it in the location already.
Absolutely, absolutely. And so I think what you're going to see, again, is just software vendors actually having acceleration capability in compute engines and architectures that will lower the need to move data and increase the speed of these vector matrix multiply operations without having to move data as much.
Nathan, before I wrap things up, my last question for you is really, if I'm a business and I want to use AI ML and I understand it, what are some advice that you give businesses when they reach out to you and say, hey, listen, AMD, here's what I'd like to do? What advice would you give them?
So I think the first is you really want to understand what compute options you have out there, right? Whether you're looking at a specific region or a specific part of AWS, there are different types of instances available in the different regions. But once you understand the types of compute that you have available to you, you should definitely reach out. We will arm you with all the data. We will arm you with all the code to replicate that data, and we will consult with you on how you can customize that code to replicate the same types of results, comparatively speaking, with even your own code. And that is going to form the basis for how you go and make, it's the basis for the analysis behind making the decisions to invest in a specific compute architecture. And so I think, definitely reach out. We could help out a lot.
Reach out and help out. Well, Nathan, thank you so much for your time here. I really enjoyed our conversation.
Yeah. Thank you, John. Loved it.
All right, everybody, real quick, we're going to wrap things up. We're scaling AI and ML on AMD and AWS. We're talking with Nathan from AMD. This has been another awesome episode on the John Myer podcast. Don't forget to hit that like, subscribe, and notify because we're out of here.